Just a moment, madam. Wait for a moment.
Okay, sir.
Start, madam.
Hello, good morning, students. Welcome back to the chemistry classes. We have already started the chapter that is stoichiometry. Today we will be having part 3 of it. Okay. Yesterday, what have we learned? We have learned about uncertainty in measurement. Okay. Rules for determining the number of significant figures. Rules for calculating with significant figures. Dimensional analysis. That is, whenever we are going to do some mathematical operation, we have to see that the quantities are expressed in the same units. Okay. And we have also seen the atomic weight and atomic mass. The difference between that we have seen. Atomic mass is the sum of the nucleons. It is the sum of the protons and the neutrons. That is nothing but the number of nucleons is what is called as atomic mass. Whereas atomic weight, it is the average of the weights of all the natural isotopes of an element. Okay. And we have also yesterday discussed about molecular mass and how to calculate it. Okay, we have seen certain examples. Okay. And we also have learned about formula mass. Formula mass is nothing but it is the molecular mass of the ionic compounds. Okay. And today we will be discussing a very important concept, that is mole concept and molar masses. Okay. And already you have learned this in your 9th as well as in 10th classes. Okay. So let us see what it is. So mole. What is one mole? Mole is nothing but it relates to the amount of a substance. Okay. A mole of a substance is defined as the amount, that is mass of a substance containing elementary particles. So what are elementary particles? They are nothing but it could be the atoms, molecules or ions in 12 grams of C12. Okay, 12 grams of C12 is what? Isotope of carbon. Okay, C12 atom. So that means, let us simplify this. We are taking about 12 grams of carbon. Why we have to take only carbon? Carbon is the universal element. That means it is present in almost every compound that is occurring in the nature. So that is the reason why we are considering as carbon the standard element. Okay. So if we are taking 12 grams of carbon atoms, it contains 6.022 into 10 to the power of 23 atoms. This number is important. Okay. So this number is what is called as Avogadro's number. Okay. So whenever we are taking a substance, its molecular weight equal to its molecular weight. So whenever we are taking some substance means what? It will contain some mass, some weight, right? So if that weight is equal to the molecular weight, then how many entities are present? Entities means how many molecules or ions or the atoms. Okay. How many are present means it has 6.022 into 10 to the power of 23. And this number is called as Avogadro's number. Okay. Similarly, one more example, let us see here. 1 mole of oxygen atoms contain 6.022 into 10 to the power of 23. Here only 2 is omitted. Okay. 6.02 into 10 to the power of 23 atoms of oxygen weighing 16 grams. Okay. Yesterday I told you to learn the atomic weights of the elements, first 20 elements. Did you all learn? I hope you have learned, right? So the atomic weight of oxygen is 16. So if we take 16 grams of oxygen atoms, okay, it has about 6.02 into 10 to the power of 23 atoms. That means 16 grams of oxygen contains 6.02 into 10 to the power of 23 atoms of oxygen. So this is again given in a easier form. Let us see here. 1 GMM. What is GMM? Gram molecular mass. Okay, that means the weight equal to the molecular weight. That is what is called as gram molecular mass. 1 gram molecular mass of the substance is what is called as 1 mole of that substance. Okay, and 1 mole, it has how many molecules? It will be having Avogadro number of molecules. So what is Avogadro's number? 6.02 into 10 to the power of 23 molecules. Okay, this blindly it has to come into your mind. Whenever we say 1 mole of a substance, means the weight will be equal to the molecular weight of that substance. Okay, and 1 mole will be having Avogadro number of particles. So what is Avogadro number? 6.02 into 10 to the power of 23. Okay, and the substances, we have studied that the substances are existing in 3 types. That is, it can be 3 physical states. That is, it could be a solid, it could be a liquid, or it could be a gas. Okay, suppose if the substance is a gas, okay, 1 mole of a gas, it will be occupying 22.4 liters at STP. Okay, so 1 mole of a gas occupies how much volume? 22.4 liters. Okay, and we know that 1 liter is equal to 1000 ml. This one. So let us see further more examples. You will understand it better. Yeah. See here. Substance. Here an example is taken as sulfur dioxide. So what is the formula of sulfur dioxide? SO2. Okay, sulfur dioxide is SO2. If I take 1 mole of sulfur dioxide, its weight will be equal to the molecular weight of sulfur dioxide. So what is the molecular weight of sulfur dioxide? Weight of sulfur plus weight of 2 atoms of oxygen. That is 32 plus 2 into 16. So it is 64. So 1 mole of sulfur dioxide, its weight would be equal to 64 grams. Okay. And we know that sulfur dioxide is a gas. So because it is a gas, its volume would be 22.4 liters at STP. So what is this STP? STP is nothing but standard temperature and pressure. Okay. So at STP, the volume of a gas would be 22.4 liters. And because it is 1 mole will have how many molecules? It will be having molecules equal to the Avogadro's number. What is Avogadro's number? 6.02 into 10 to the power of 23. So this is Avogadro's number. Okay. And in your IIT exams and other competitive exams, they also ask you about the number of atoms present present in a compound. So here you see here, SO2, it is made up of sulfur and 2 oxygens. So 1 mole of this we having Avogadro number of sulfur atoms and 2 into Avogadro number of oxygen atoms, because the formula contains O2. So 2 into Avogadro number of oxygen atoms. So simply how to come to know that is, you have to observe the formula. The formula is SO2. So 1 mole will be having 1 Avogadro number of sulfur atoms, 2 Avogadro number of oxygen atoms. Okay. Next, let us see another example. Calcium chloride. That is CaCl2. Okay. If we take 1 mole, its molecular mass is 111 grams. Okay. Volume at STP, we are showing it as a dash. Why? Because it is a solid. Okay. For solids, we do not measure the volume, we measure the weight. So the weight is 111 grams. Okay. So because the weight is equal to the molecular weight, its molecules would be equal to the Avogadro number of molecules. That means CaCl2, how many molecules are there? 6 into 10 to the power of 23. You can round it off to 6. So sometimes they'll be giving you in the exact figures, that is 6.02, or sometimes they can simply round it off to 6. Okay. And you observe this. Calcium chloride, it is an ionic compound. How to know that whether a compound is an ionic or non-ionic? How do we know? We have to learn the elements of the group. First A group, second A group elements are metals. They will be losing the electrons. Okay. Once a substance, once a element loses the electrons, it forms the ion. So that compound would be an ionic compound. So calcium chloride is ionic. How do we come to know? Means calcium belongs to second group. So second group means what? They will be losing the electrons. And chlorine belongs to 7th A group or the 17th group. It needs 1 electron. This you have learnt in your periodic classification of elements. Okay. So calcium chloride is an ionic compound. So how many ions would be there? Let us see here. In the formula, we are having only 1 calcium, Ca. So it will be having Avogadro number of calcium ions. And how many chlorine ions are there? 2. So the total number of chloride ions in 1 mole of calcium chloride would be 2 into Avogadro number of ions. So 2 into 6.02 into 10 to the power of 23. Okay. Hope you have understood. This is very, very important relation. You have to learn this and understand. Please do not mug up. If you understand it, you can solve so many problems. If you go by formula wise, it would be very hectic for you to learn. Understand the concept. 1 mole means its weight would be equal to the molecular weight, and it will be containing Avogadro number of molecules. And if it is a gas, its volume would be 22.4 liters at STP. And how many total number of atoms would be present means just by seeing the formula you should say. Okay, calcium chloride, 1 calcium, 2 chloride. So total of 3N. N is Avogadro's number. 3N ions would be present. In that way you should understand. So let us see one example. How many moles of NaOH? What is NaOH? Caustic soda, sodium hydroxide. Okay. How many moles of NaOH are present in 160 grams of it? So whenever the problem is given, you please just see the formula, then calculate its molecular weight. So what is the molecular weight of NaOH? It is 40 grams. So each sodium is 23, 1 oxygen 16, 1 hydrogen 1. So total it is 40 grams. So if it is 40 grams, it would be 1 mole. But how many grams are given? 160 grams are given. So how many moles? It is simple a cross multiplication only. 40 grams is 1 mole. 160 grams is how many moles? So it is upon cross multiplying, you will get it as 160 by 40. That is nothing but 4 moles. Next. The another subtopic is formula for calculation of equivalent weight of substance. Okay. So we have till now we have seen about the atomic mass. Okay. Atomic weight, molecular weight, formula weight we have seen. Okay. Now we would be seeing equivalent weight. So what is this equivalent weight? Let us see. Okay, equivalent weight. So equivalent weight of an acid. It is, the formula is nothing but the molecular weight of the acid by basicity of the acid. So what is basicity, we need to know. So tell me a few examples of the acids, recall once. One of the acid present in our stomach, what is that present? HCl, hydrochloric acid. Okay, so what the formula is HCl. So how many hydrogens can this HCl lose? It can lose only one H, one hydrogen ion can be lost. Okay, what happens is actually the bond between the HCl is broken, so the electron of hydrogen is taken by chlorine. So hydrogen would be lost as H plus ion. Okay, so we can say that HCl will lose one H plus ion. So 1 is the basicity of hydrochloric acid. Okay, so what is basicity? Let us define it. The number of replaceable H plus ions is called as basicity of the acid. Okay, so for HCl, the basicity is 1. So how to calculate the equivalent weight of this HCl? Molecular weight of HCl divided by 1. Okay. Another example, you please make a note of it. Another example, you take it as sulfuric acid. So what is sulfuric acid? H2SO4. Okay. Whenever we hydrolyze this sulfuric acid, okay, whenever we are adding some water, what happens is it breaks up into the ions. So it would give 2 H plus ions and 1 SO4 minus 2 ion. Yesterday I told you to learn the ions, polyatomic ions. So what is sulfate ion? SO4 minus 2. Okay. How do we get this sulfate ion? When sulfuric acid undergoes ionization. Okay. So it will be giving 2 H plus ions. That means what? The basicity of sulfuric acid is 2. So how to calculate the equivalent weight of sulfuric acid? Molecular weight of sulfuric acid by 2. What is the molecular weight of sulfuric acid? Yesterday I gave you the homework, I think. The molecular weight is 98. So 98 by 2 is 49. So 49 is the equivalent weight of sulfuric acid. Hope you have understood this. Okay. Please practice and learn on the same day itself. Next, let us see equivalent weight of a base. Okay, already you have learned what are bases in 10th class, acids, bases and salts, that chapter. Okay, bases are nothing but the substances which are bitter to taste. Okay, they turn red litmus to blue. All these you have studied, and generally we need to know that bases will be giving OH minus ions. So what are OH minus ions called as? Hydroxide. Okay, they will be giving the hydroxide ions in the water. So just now we have seen an example, NaOH, what it is called as? Caustic soda, sodium hydroxide. Okay, so whenever you carry out ionization of this, that means whenever we add water to this NaOH would be breaking up into Na plus and OH minus ions. So how many OH minus ions we got? Only 1. That means 1 is the basicity, 1 is the acidity of the base. Okay, for acids we have to say basicity of the acid. For bases we need to say acidity of the base. So what is acidity of the base? Number of replaceable OH minus ions. Okay, so one example we have just now discussed is sodium hydroxide, NaOH. Okay, let us take another example. Magnesium hydroxide, you have learned. What is the use of this? Antacid. Magnesium hydroxide is used as an antacid. It is used to treat the acidity. So what is the formula of that? MgOH taken twice, magnesium hydroxide. Okay, so whenever we carry out hydrolysis, So it would be giving 1 magnesium ion and 2 hydroxide ions. So 2 is the acidity of magnesium hydroxide. So how would you calculate the equivalent weight of magnesium hydroxide? Molecular weight of magnesium hydroxide by 2. So that is the equivalent weight of the bases. Okay. All these applications of these you will be learning in your future classes. So better learn it here itself. These equivalent weights. Next, equivalent weight of a salt. So what is this? Let us see here. Equivalent weight of a salt is nothing but formula weight by valency of the metal atom. So we are here, it is saying that formula weight. So formula weight means it is the molecular weight of the ionic compound. So what do you understand? Salts are ionic compounds. Okay, that we have to infer from here. That is the information we can obtain. Salts are ionic compounds. And for ionic compounds, we calculate the formula weight. So equivalent weight of a salt is nothing but formula weight divided by valency of the metal atom. So let us deal with an example. What is the common salt we are using? Sodium chloride, NaCl. Yes or no? Yes, NaCl is the common salt. So if you calculate the weight of NaCl, what is the atomic weight of sodium? 23. Atomic weight of chlorine is 35.5. So the sum of this is 58.5. This is the formula weight of NaCl. Okay. Now valency of metal atom. So what is the metal in NaCl? Sodium is the metal in NaCl. Okay. So what is the valency of sodium? 1, because it belongs to first A group. Sodium belongs to first A group. So its valency is 1. So what is the equivalent weight of NaCl? Nothing but formula weight of NaCl by valency of sodium. So that is 58.5 divided by 1. That is the equivalent weight of NaCl. Okay. Next. In redox reactions. So while discussing the objectives, I have already told you what are redox reactions. The name itself says red. Red means it stands for reduction. Ox, it stands for oxidation. So redox reactions are those in which both reduction and oxidation takes place simultaneously. Okay. So whenever reduction and oxidation is going on, so what is reduction and oxidation? Nothing but it is the loss or gain of electrons is reduction, loss of electrons is oxidation, gain of electrons is reduction. So whenever a substance is losing the electron, another substance will accept it. Okay. So how many ever electrons are being lost or gained? That is what is called as change in oxidation number. Okay. So equivalent weight of an ion is nothing but formula weight divided by change in oxidation number. Okay. So this is about the equivalent weights of the substances. Okay. And next topic in your textbook is about methods of expressing concentration. That is deleted for this year. Okay. Next, let us see the equivalent weight of an element. Okay. So what is an element? Element is a substance made up of one kind of atoms. Okay. And how many elements are there? Total of 119 elements are there in the nature. Okay. Hydrogen, helium, lithium, all these are the elements only. Okay. So let us see what is the equivalent weight of an element. So the equivalent weight of the element is nothing but it is the atomic mass of the element by valence of the element, valency. Okay. So what is valency? Valency is nothing but it is the combining capacity. Okay. So how it is combining? Why actually combination reactions takes place? What is valency? Combining means actually the atoms are unstable. So they will be combining, they will be reacting to form the molecules. They will be combining to form the molecules. Okay. Because molecules are stable, atoms are unstable. Okay. And first A group elements, their valency is 1. Second A group elements, their valency is 2. Okay. So valency of an element is nothing but atomic mass of the element divided by valency of the element. So for example, let us see equivalent weight of sodium. Okay, we know that sodium belongs to first A group. So what is the equivalent weight of sodium? 23 by 1. So 23 itself. Whereas coming to magnesium, magnesium belongs to second group. So equivalent weight of magnesium is 24 by 2. So it is 12. Whereas coming to third A group element, that is aluminium. So what is the equivalent weight of aluminium? Atomic weight of aluminium by valency of aluminium. Atomic weight of aluminium is 27. Okay. And because the valency of aluminium is 3, so now equivalent weight is 27 by 3, that is 9. Okay. So this is about equivalent weight of an element. Yeah. Next, coming to percentage composition. So what is composition? Composition is nothing but it is the substance with what it is made up of. Okay, the substance with what another substance is made up of. For example, if I say water, so what is the formula of water? H2O. So what do you understand from that? Water is made up of 2 hydrogen atoms, 1 oxygen atom. Okay, so this is the composition of water, hydrogens and oxygen. So what is the percentage of hydrogen and what is the percentage of oxygen? We would be calculating it. That is what is percentage composition. So let us see what it is. Percentage composition of a compound gives the relative amount of each element present. Okay. So how much amount of a particular element is present in the compound, we will be coming to know by using the percentage composition. Okay. For example, let us see here. Percentage is equal to mass of the element by mass of the compound into 100. Mass of the element by mass of the compound into 100. And we need to know that the sum of the percentages of each element. Okay, suppose we are taking water. Water means 2 hydrogens and 1 oxygen. Okay, so if we are seeing the percentage of hydrogen and percentage of oxygen, if you are adding up, we have to get it as 100%. Okay. So let us see one example. We'll understand it better. Yeah. See what is given. Calculate the mass percent of the different elements present in sodium sulfate. Okay. So first we need to write down the formula of sodium sulfate. So what is the formula of sodium sulfate? The formula of sodium sulfate is Na2SO4. Okay. And we have to know the molecular weight of it. So The molecular weight of Na2SO4 is 142. Okay, yesterday we have seen how to calculate the molecular weights. Weight of 2 sodiums, 1 sulfur, and weight of 4 oxygen atoms. If you add this, you'll get the sum as 142. So 142 is the molecular weight of sodium sulfate. Okay, now mass percentage of an element. So what is the formula? Mass of that element by molar mass into 100. Okay, so let us see here. Mass percentage of sodium. So mass percentage of sodium is nothing but the total weight of sodium in sodium sulfate is 46. So 46 divided by 142 into 100. So upon simplification, you'll get it as 32.39. Okay. Similarly, calculating the mass percentage of sulfur. Here only how many sulfurs are there? Only one sulfur. So what is the weight of sulfur over here? 32. So 32 divided by 142 into 100. This upon calculation, you will be getting it as 22.54. Okay. So mass percentage of sulfur in sodium sulfate is 22.54%. So now let us see mass percentage of oxygen in Na2SO4. So how many oxygens are there? 4 oxygens. And weight of each oxygen is 16. So 4 into 16 is 64. So 64 divided by 142 into 100. So it is 45.07. Okay. So 45.07 is the mass percentage of oxygen in sodium sulfate. Okay. So now when you add up all these 32, that is mass percentage of sodium, sulfur and oxygen. So what total you should get? You have to get the total up to 100%. Okay. Hope you have understood it. So please go through the textbook and work out on the problems given at the end of the textbook, end of the lesson. Yeah. Next important topic is empirical formula. So what is empirical formula? Let us see. Empirical formula, it represents the smallest ratio of atoms present in a compound. Okay. It is the smallest ratio of atoms. This is important. Smallest ratio of atoms. So what is this? Let us see. One example, simple example. We'll take glucose. What is the formula of glucose? C6H12O6. Yes or no? And here, all these elements, that is carbon, hydrogen, and oxygen, they are the multiples of 6. 6 carbons, 12 hydrogens, 6 oxygens. So you can cancel it in 6 table. 6 ones are, 6 twos are, 6 ones are. So that means we'll get it as 1 carbon, 2 hydrogens, and 1 oxygen. Okay. So CH2O is the empirical formula of glucose. Okay. Please make a note down of it. Please write it down simultaneously. What is glucose? C6H12O6. Okay. Make the simple ratio of the elements. All these can be divided by 6, right? So upon simplification, we would be getting as CH2O. So CH2O is the empirical formula of glucose. Okay. Now let us see. What is molecular formula? The molecular formula gives the total number of atoms. Okay. It gives the total number of atoms of each element present in one molecule of a compound. Okay. This is important. Molecular formula gives the total number of atoms. Okay. Of each element present in one molecule of the compound. For example, that's what glucose, C6H12O6. That means how many carbons are there, how many hydrogens are there, how many oxygens are there. you will understand by seeing the molecular formula. Okay. By seeing the empirical formula, you will come to know what elements are there, but exact number of elements you will not come to know. Okay. Next, the empirical formula is the simplest formula. Empirical formula is the simplest formula, and the molecular formula is the true formula. Okay. Now make a note of it. See, what is hydrogen peroxide? H2O2. Okay, H2O2. So what would be the empirical formula of hydrogen peroxide? HO, because 2 if you cancel it, simple, we are making it as a simple ratio. Okay, so HO would be the empirical formula of hydrogen peroxide. Okay, H2O2 is the molecular formula of hydrogen peroxide. Yeah. Next, we'll see another problem. See the problem. The empirical formula of a compound is CH2O. Okay. That means, what do you understand? The compound is made up of carbon, hydrogen, and oxygen. Okay. And the ratio between them is 1:2:1. 1 carbon, 2 hydrogens, and 1 oxygen. The ratio I'm saying, not exact number of atoms. That is the ratio. Okay. Its molecular weight is 90. The molecular weight is given. Okay. Calculate the molecular formula of the compound. Okay. So we are given the empirical formula, that is CH2O. Okay. Molecular weight is given. Okay. Empirical formula is given. Molecular weight is given. We have to calculate the molecular formula. Okay. So there is a relation between empirical formula and molecular formula. So let us see what it is. The relation between the empirical formula and molecular formula of a compound is, molecular formula is nothing but empirical formula taken n times. Okay. If you multiply the empirical formula with a particular number, with a particular integer, you will get the molecular formula. Okay. So what is this n? Let us see. N is nothing but molecular weight by empirical formula weight. What is N? Molecular weight by empirical formula weight. So in the above problem, it is given that the molecular weight is 90 and empirical formula is CH2O. So let us calculate the empirical formula weight. So what it is? 30. 12 is the weight of carbon, 2 is the weight due to hydrogen, 16 is the weight due to oxygen. So it is 30. So let us see the calculation of N. N is nothing but molecular weight by empirical formula weight. So 90 by 30. So it is 3. Okay. So we got the value of N. We know the empirical formula. Now we have to write down the molecular formula. So what is the molecular formula? The molecular formula is CH2O taken thrice. That means now you multiply this 3. Okay. Multiply this 3 to these elements. So we will be getting it as C3H6O3. Okay. I hope you have understood it. Next. Next important subtopic is steps to find the empirical formula from the given data. Okay. So generally the questions you will be getting, it can be asked for 4 marks. Okay. So they will be giving you a particular compound. It contains some amount of hydrogen, some amount of carbon, some whatever the composition is there, they will be giving you the percentage composition. Okay. And from that percentage composition, you are supposed to find out the empirical formula. Okay, sometimes they can ask you to find out the empirical formula. Also, sometimes they'll ask you to find out the molecular formula. Okay, so what are the steps? Let us see. Assuming 100 gram of the sample. Okay, convert the mass percentage of each element into grams. So suppose in the problem it is given as 23% of sodium. So what you have to understand, 23 grams is sodium. Okay, the weight of sodium is over 23 grams. That you should understand. Suppose if it is 50 grams of X, so 50% means 50 grams you should take. 35% means 35 grams you should take. That we have to do. Then divide that mass, okay, by the molar mass. Okay, so molar mass is generally here we'll be using the elements only, right? So we have to divide that mass by atomic weight. Then we will be getting the number of moles. Then we will be calculating the mole ratio to obtain the empirical formula. So we'll see few examples. Yeah, this is the example given in your textbook. Okay, see here, what is given in the textbook? A compound contains 4.07% hydrogen, 24.27% carbon, 71.65% chlorine. Its molar mass is 98.96. What are its empirical formula and molecular formulas? So first thing what we have to do, we have to convert these percentages into the grams. So 4.07% hydrogen means what? 4.07 grams of hydrogen. Next, 24.27% of carbon means 24.27 grams of carbon. That is a very simple step. The percentage has to be written as grams. So that is the first step. So next step what it is? Conversion into number of moles of each element. So how do you get the number of moles? Given weight by molecular weight is the formula to calculate the number of moles. Weight by molecular weight will give you the number of moles. So here in the first step you have got the weights, right? Now for each element we have to calculate the number of moles. So see, moles of hydrogen. So what is the weight of hydrogen? 4.07 by 1. You can approximately take it as 1. Okay, so 4.04 you are getting. So moles of carbon, what it is? 22 weight, given weight is 24.27. And what is the atomic weight of carbon? 12.01. So if you divide 24.27 by 12.01, you would be getting it as 2.021. Same thing, you are calculating the moles of chlorine, 71.65 by 35.5. This is the atomic weight of chlorine. So this is about the second step. So next step what it is? Divide the mole value obtained above by the smallest number. So in that case we have got the moles of each elements. So among that you have to observe which one is the smallest value. You have to select that value and divide all the moles with that particular smallest value. Okay, so in that example we are getting the smallest value is 2.02 is the smallest value. So we are dividing all these with 2.02. Okay, then after dividing with the smallest value we will be getting the ratio of the elements. Okay, we would be getting the ratio of the elements. Okay, these numbers, okay, indicate the relative number of atoms of the elements. By using that we have to write down the empirical formula. Once we get the ratio, that is what is the empirical formula. Okay, and in the problem what it is given, molecular weight is given. So writing the molecular formula. What is the relation between empirical formula and molecular formula? Empirical formula taken n times C is the molecular formula. Okay. So for that, first we have to calculate the empirical formula weight. Okay. Then we will be getting the n value and multiply the n value with the empirical formula. You will get the molecular formula. Okay. So this is what is the example given in the textbook. Please go through it. So see here. I have given you a very simple question over here. A carbon compound contains 12.8 grams of carbon, 2.1 gram of hydrogen, 85.1% of bromine. The molecular weight of the compound is 187.9. Calculate the molecular formula. So better draw a box like this and do it. It would be very easy for you. So what is the first step? We have to write down the percentage composition. In the first column, you write down the elements. What are the elements? Carbon, hydrogen, bromine. One by one you write. Their percentages you write. 12.8, 2.1, 85. Now converting into the moles. Okay. So how to convert? We have to divide these weights by their atomic weights. 12.8 by 12. Because 12 is the atomic weight of carbon. 1 is the atomic weight of hydrogen. 80 is the atomic weight of bromine. That we are doing. So upon doing that, we are getting the number of moles. Now observe among these three values, 1.06, 2.1, 1.06. So among these three, which is the smallest one? 1.06 is the smallest one. Two values are common, 1.06 and 2.1. So 1.06 is smallest. So we are dividing these three values with 1.06 each. So you see 1.06 by 1.06, 2.1 by 1.06. So upon doing this, you will be getting the smallest number. Okay. So here we are getting it as 1. Here we are getting it as 1.9. That is approximately 2. Okay. And this is 1. So 1 carbon, 2 hydrogens, 1 bromine. This you have to understand. Once upon dividing, we are getting the smallest number. These are the number of elements. So this number pertains to this element, carbon. This 2 pertains to hydrogen. 1 pertains to bromine. So CH2Br is the empirical formula. Okay. And in the problem, they are asking us to find out the molecular formula. So they gave us the molecular weight. Once if you know the empirical formula, you have to calculate the empirical weight, divide that empirical weight with the molecular weight. Molecular weight divided by empirical weight will give you N. Once you get N, you have to calculate the molecular formula. So students, today let us complete with this. So you please go through the textbook, go through the problems given at the end of the chapter. Okay. And please practice these problems. They can be asked for 4 marks. This is very, very important chapter. Okay. Problems can be asked based on 2 marks. They will give you empirical weight, molecular weight, and they'll ask you to find out the molecular formula. That can be given for 2 marks. Okay. Now, just giving the percentages compositions, they can ask you to find out the empirical formula as well as molecular formula. So please go through this. As well as we have discussed the mole concept. 1 mole of a substance has Avogadro number of particles. And if it is a gas, it occupies 22.4 liters of volume. And its weight would be equal to the molecular weight. Okay. So please go through this topics. Okay. This is very, very important. Please solve it.